Hey, this is Mrs. Harris and this is Math for You. Today I'd like to continue our discussion on solving algebraic equations for different variables. In the equation I have down below, I have two variable terms on the left-hand side of the equation. And here is my left-hand side. I have a variable term of 8x and a positive variable term called 4y. And that is going to equal, on the right-hand side, a constant of 12. I would like to go ahead and solve for y, so I'm going to go ahead and give myself that visual cue and go ahead and highlight or box or circle with a different colored pencil the variable that I'm looking for. I'm also going to go ahead and put my brick wall in, so I know that whatever I do to one side of the equation, on the left-hand side, for example, I have to go ahead and do to the right-hand side. So I'm trying to isolate or get y all by itself. So the first thing I'd like to do is I'm going to go ahead and subtract a variable term called 8x from this left-hand side. Now whatever I do to one side of the equation, I have to make sure I do to the other. So I'm going to go ahead here and subtract a variable term called 8x from that right-hand side. And go ahead and draw my line right here and bring down my equal sign. And I can see that a positive 8x variable term, and when I add a negative 8x variable term, that will go to 0. And that leaves me just 4y on my left-hand side. And on the right-hand side, I have a constant term of 12. 12 is a constant term. Now, because it is a constant, and over here I have a variable, I know that I can only add and subtract like terms. So the 12 is a constant term and the negative 8x is a variable term. So I need to write it as a constant minus a variable term. So I'm going to go ahead and just write that just like this. So now I can see that I'm still looking for my y term over here, so I'm going to go ahead and highlight it or circle it to give myself that visual cue that I'm still looking for the y term, but I don't want 4 times y, I just want y. So I'm going to go ahead and divide each side of the equation by the coefficient of this variable term, which is 4. So I'm going to divide the left-hand side of the algebraic equation by 4, and I'm going to divide the right-hand side by 4. I'll see over here on the left-hand side that we have a 4 divided by a 4, and that's going to go ahead and reduce down to a 1. So that's just going to leave me a y on that left-hand side, and y is going to be equal to, I'm going to go ahead and divide each term by 4. So I'm going to have 12 divided by 4 minus 8x divided by 4. Now what I'm going to go ahead and do is, I still have y, and that's equal, 12 divided by 4 is going to give me a 3, 8 divided by 4 is going to give me a 2, and because of that negative sign, I have to, don't forget it, it's a negative 2x. Now I'm done here, but if I'd like to write this in a form of y equals mx plus b, which is my slope-intercept form, I'm going to go ahead and rearrange these terms. When I go ahead and rearrange these terms, I can't just simply put this 2x variable term in the front. I have to carry the whole term to the front. And this whole term is a negative 2x. Don't forget that negative sign. You don't want to forget it. You want to go ahead and make sure you capture the whole term, including its sign. So y is going to be equal to minus 2x, and this is a positive constant term, so it's a positive 3. So this is my answer. So if you see this on an exam or an assessment, and you know that you have to rearrange the terms, put one in front of the other, don't forget, go ahead and give yourself that visual cue and go ahead and circle it, highlight it to make sure that you pick up that sign. Because if you don't and you just write 2x minus 3, then the problem will be incorrect. So let's go ahead and take a look at one more example. I'm going to have the formula that some volume is equal to 2 pi r divided by t. And in this particular problem, I don't want to solve for v, but I want to solve for the variable in the denominator, t. Now there are a couple of ways that we can attack this. Some people just see, well, this numerator is divided by a t in the denominator. So this is division. The opposite operation of division is multiplication. So some people will just see, well, I just want to multiply each side of the algebraic equation by t. And because this is in a fraction, I'm going to go ahead and put this in a fraction as t over 1. A lot of times students get confused and think, well, there's no numbers. I can't make anything or solve anything because there's no numbers down here. This is just a variable term. It means t could be any number you want it to be, any integer, positive or negative. It could even be a fraction. So if I had 5 on the bottom, I'd know that I'd multiply by 5 over 1. Just because I have t means I'm going to use the inverse of 1 over t, which is t over 1. So I'm going to multiply each side by t over 1, because whatever I do to the right-hand side, I also have to do to the left-hand side. So I can see over here that this term and this term will reduce to 1. So now I just have on that right-hand side my numerator, 2 pi r, and on the left-hand side I have t times v. But I don't want t times v. I'm still looking just for the variable t. So the opposite of multiplication is going to be division. So on this left-hand side, I'm going to divide by the variable v. I'm dividing by the one that I haven't circled. When I circle or highlight that variable that I'm trying to solve the equation for, I'm not going to touch it. I'm trying to leave it alone and just solve in terms of t. Put my brick wall up. I'm going to divide the right-hand side also by v. I can see that on the left-hand side, that a v divided by a v, both of these are the same variable, are going to reduce down to 1. So that's just going to give me t equals. Now, pi we're going to leave alone. R is some variable, it's probably the radius, and v is a volume. Since these are not like terms, I cannot combine them. So I'm just going to write 2 pi r divided by v. And this is the answer. This is the original algebraic equation now solved for t. Like I said, sometimes students have a hard time seeing that just because there's a letter in the denominator, that it does have a reciprocal. Alright, so let's say that you didn't see that problem that way. How is another way that you could solve this problem or problems similar to this? So we have our original equation that the volume is equal to 2 pi r t, and we're going to go ahead and give ourselves that visual cue and know that we are going to be solving for the variable t. You may want to go ahead and just rewrite this problem. The left-hand side I'm going to go ahead and leave alone because it's just v, so I'm just going to rewrite a v, and that is equal. I'm going to pull out the fraction here. I'm going to say on the right-hand side it's 1 over t times the quantity of the numerator. I'm just going to rewrite the numerator. Because this expression right here is the exact same as this expression right here. They are equivalent or equal expressions. I'm just pulling out the fraction. And 1 over t, even though t is a variable term, it's still a fraction. So now I can see that I have a fraction, and whenever I have an algebraic equation that has a fraction, I want to multiply both sides of the equation the right-hand side and the left-hand side by the reciprocal of my fraction. And the reciprocal of 1 over t is t over 1. Sometimes when you put it this way, you can see that you had a fraction and maybe it's a little bit easier for you to start the problem. So a t, and here's another t divided by t is going to reduce to 1. And this over here, they are not like terms, so I cannot combine unlike terms. I have to write it as t times v, and that will equal the 2 pi r. Now, again, I want to go ahead and circle that variable. Circle the variable that I am looking for. And I will know that I want t. I don't want t times v, so the opposite of multiplication is going to be division. So I'm going to go ahead and divide both sides of my equation by the variable that I am not trying to solve for. And I'm going to go ahead and put my brick wall down. And I'll see that the v's will go ahead and reduce to 1. So I have t is equal to 2 pi r divided by v. And it's exactly the same answer we got when we did it originally, but this way I went ahead and I pulled out the fraction so that you could see that there was a fraction there, and whenever we have a fraction and we're trying to rearrange terms or solve for another variable in an algebraic equation, we have to multiply by the reciprocal. So go ahead and look back at these examples, try some more in your homework, or look over the assessment that you just took and see if these make a little bit more sense for you. I'll see you in class tomorrow, and again, this is Miss Harris, and this is Math for You.